Let's talk a bit about percents. Now, we talked about percents in the last unit, particularly converting percents to decimals and decimals to percents. And I want to take a quick look at that again, just recapping what we did just to make sure we're all up to speed. If I have a number like 54%, for example, and I want to turn that into a decimal, the easiest way to do it is say I'm going to divide it by 100. Dividing 54% by 100 is going to give you 0.54. Instead of saying you're dividing it by 100, you can also just move the decimal point when you divide by 100. It means you take the decimal that's here and you move it 1, 2 to the left, and it becomes 0.54. So if you want to do that in your head, or if you want to show that work, you can do that. You can also just divide it by 100. If I have something like 123%, and I want that as a decimal, same thing, divide it by 100. The decimal here will move twice, 1, 2, and you'll get 1.23. If I have something like 6%, and I want that as a decimal, again, divide it by 100, and you'll get 0.06. Right, the decimal used to be here next to the 6. It moved over twice. Now it's here. When you move it that second time, it makes a 0 in this position. So if you see a decimal like 0.06, remember that's 6%, not 60%. Right? If I'm talking about 60% and you divide that by 100, you will get 0.6. So this is 6%. This here is 60%. Make sure you're aware of the difference between those. Now, if I have 0.5%, right, or in other words, 0.5%, which is something that you can have, definitely, and you divide that by 100, you will get 0.005, right? If it was 0.05, it would be 5%, so it's 0.005. If we're talking about 0.5%, okay? Again, that decimal point just moves twice. The decimal used to be here next to the 5. It moved 1, 2 to the left, just like that. So we have to be comfortable turning percents into decimals. We also know how to do the opposite, right? If you have a decimal like this and you want it as a percent, instead of dividing by 100, you would take this number and you would multiply by 100, which means you move the decimal to the right twice, and it turns into 54%. It's more frequent, though, that we have to do what we're talking about here. Definitely more frequent that you're given a percent and you have to turn it into a decimal than the opposite, particularly for word problems and applications, but it is important that you know how to do both. Now, one question that you could be asked is something like this. What is 40% of 1,000? Well, this is why it's so important to be able to turn percents into decimals. This 40% we know as a decimal is 0.4. To find out what 40% of 1,000 is, you simply do 0.4 multiplied by 1,000. And in this case, that is going to equal 400. So 400 is 40% of 1,000. Now you might say that one's kind of easy because, 40 is 40% of 100. So of course 400 is 40% of 1,000, right? They're proportional. This one makes sense. But you can have some that are more difficult. Something like this. What is 27% of 362? 27% as a decimal is 0.27. Multiply that by 362. And of course, you're allowed to use your calculator for these types of questions. This will give you 97.74. So 97.74 is 27% of 362. This answer should make sense to you, I think. 0.27, 27%, that's in between a quarter and a third, right? 25% would be a quarter. 33% would be almost a third. This number is in between those two. And so the answer you expect to get would be somewhere between a quarter and a third of 362. If you think of what a third of 362 is, well, that would be about 120, a little bit more. And so this is less than that, certainly. And a quarter of 362 would be about 90. So this number is certainly between those two. You don't have to go through that math in your head. I'm just thinking out loud of what my brain would be thinking of when I get this type of question, just so I know what type of answer to expect. But the actual math you have to do here is just this. 27% of 362 to 0.27 times 362, and you get your answer. That's it. Now this leads me to something that we call the portion formula. The portion formula is something that looks like this. R is equal to P over B. The R in this equation stands for the word rate. So I'll actually write that out. Rate. The P is portion, and the B is base. This is a formula that you can manipulate any way you want and use to solve for different parts of these word problems. So when we say the word rate, we're talking about the percent. In the previous example that we looked at, the word rate would be that 0.27, the decimal that represents the percent. The portion is the part of the number that is just a portion of it, right? So in the last example, the portion would be that 97, right? 97 is a portion of 362. And of course, 362 would be the base, right? The base being the total amount that we're talking about. So just to give you a quick example, if I have a portion that is 5 and a base that is 10, I'm saying 5 out of 10. And if you divide 5 over 10, you get 0.5. The rate is 0.5, 50%. This is saying 50% is what we have here. 5 out of 10 is 50%. So you can use this portion formula to help you solve depending on what it is you're looking for. This can be manipulated, of course. So if I'm looking at this version of the equation, R equals P over B, you can multiply both sides by B and get B times R is equal to P. This is actually the equation that, or the version of the equation that we used in the last example, right? We had the base, right, the total amount. We multiplied it by the rate, right, the decimal, and we got the portion. So if you look up here, that's exactly what we did. We had the base, right, the total amount, multiplied by the rate, and we got the portion. So we've already been using this formula unknowingly, but you can now use it in a more strategic way to find whatever it is you want to find. You can also solve for B if you want. Divide both sides here by R. You would get B is equal to P over R. So you have these three different versions of the equation where R is isolated, where P is isolated, and where B is isolated. And depending on what you're looking for, you can manipulate your equation to look like either one of those, or I should say any one of those, and you can solve for whatever it is you want to solve for. Now sometimes you'll see these equations written, and you might see this in your textbook, you might see them written in a triangle like this. And you'll see this for different types of things in mathematics, but the triangle looks something like this, where you have your R over here, your P over here, and the B over here. And what this is, just so you don't get confused by it, you don't have to use it if you don't want to, but it's basically a way to remember these formulas that I've written down, these equations. So if you're wanting to solve for R, for example, the idea is you cover up the R with your hand, and what you're left with is P over B, right? P over B. So if you want to solve for R, R is equal to P over B. That's what this equation here tells us. If you want to solve for B, you cover up B with your hand and you're left with P over R. So B is equal to P over R. Well, that's what this equation here says. And if you want to find P, right, if you want to solve for P, you cover up P with your hand and what you're left with is R and B right next to each other. That means R multiplied by B. Well, that's what this equation here tells us. So if you want to use this triangle as a way to help you remember these formulas, you absolutely can. But it's also okay just to remember this and change it to this or change it to this depending on what you're looking for. You can really remember any one of these three and once you remember that one, you can adjust it to look like the other two. It's completely your call, whatever you're comfortable with. Now, let's use that portion formula down here in this question. It says, what is 15% of 237.98? So the way I read this is, because it's 15% of this, this is your base. This is your total amount, right? So what I'm looking for is the portion, right? The portion is equal to the rate times the base. So the portion is equal to 0.15, that's the rate, multiplied by the base, which is 237.98. If you do this math, you'll get portion equals 35.697. So 35.697 is 15% of 237.98. Now, if you look at the original question, this is actually a money question, right? The value is given to you here in dollars. So we should write our final answer in dollars as well. So I'll say that this is $35, and I have to round this to 2 decimal places because cents we always use 2 decimals, and that would become 70, right? I want to round this 9. The 7 tells me I have to round it up, but it becomes 10. So I don't just put a 0 here, this 6 becomes a 7. So to round that up to 2 decimals, you get $35.70, just like that. Okay, what is 123% of 47? Again, we're looking for a percent of a number. So again, this 47 is your total. It is therefore your base, right? So portion is equal to the rate times the base. You don't have to use this equation. Again, just to remind you, if you want, you can skip right to the part where you start doing the math, right? You can say portion is equal to 123 as a decimal is 1.23 multiplied by 47. So your portion is 57.81. This is a funny example because the portion actually ends up being larger than the base. And that can happen because our percent is over 100%. So that number is actually growing. It's getting larger. That's okay. This is still your final answer. All right, now let's get into some word problems. In this particular question, it's asking, in Ontario, HST is 13%. That's harmonized sales tax. So when you buy a product at a store, they always add 13% tax. The question is, how much would you pay for an item that is listed at $7.99? So you go to the store, you see an item on the shelf, it's listed at $7.99, but that's not usually what you end up paying. You usually end up paying 13% more. So what you can do is you can find what 13% of this is, right? You can say 0.13 multiplied by 7.99. And if you do this math, what you're going to get is 1.0387. So that's the amount extra that you're going to be paying in tax. If you add these two numbers together, you will get the total amount that you pay, which is really what we're being asked, right? We're being asked how much you're going to pay for the item. So 7.99 or $7.99 plus 1.0387 is equal to 9.0287. And of course, because it's a dollar question, we have to round this to 2 decimals. So this will be $9.03. So notice that I wait to the very end to round off my answer, right? I don't round this number first and then add them. I wait to the very end just to ensure that my answer is nice and accurate. Now, this is one way you can solve this question. But there's also another method that you can use, which I think is a little bit faster. Instead of multiplying this $7.99 by 13% and getting that amount here, the amount you pay in tax, and then adding it to the original, we can do this all in one quick calculation. Instead of multiplying by 0.13, I'm going to multiply by 1.13. If you do it this way, you will get your answer 9.0287, which of course you can round to $9.03. The reason this works is because the 0.13, this part, when you multiply that by 7.99, you get that amount that you pay in tax. When you multiply the 1 by the 7.99, you get 7.99, and then those two numbers add together to make this. So instead of doing those calculations separately, you can simply use 1.13. So if I know a number is getting larger by a certain percent, instead of multiplying by that decimal, I can multiply by 1 point that decimal. So if a number is getting 13% larger, I can multiply it by 1.13 to find out what that larger value will be. If I care, though, about what that particular amount of tax is that I'm paying, then you might do it the first way because that's the answer you get first, right? We end up paying about $1.03 in tax, but your total is $9.03. Okay, let's go to the next question. You are currently paid $14 per hour at your job. Your boss gives you a 10% raise. What is your new rate of pay? Okay, so you're getting $14 an hour, which I think now in Ontario is a little bit below minimum wage, but it used to be minimum wage, I think. 10% raise, so same type of question as the last one where we have an amount of money that is increasing, and they want to know what you're now going to be getting paid. So again, one way you can do this is you can say $14 an hour multiplied by, and then you have your 10%, so 0.1. If you do this, you're going to get 1.4 as your answer. Now, wait a minute, 1.4. You're definitely not making $1.40 an hour. This 1.4 represents the increase in your pay, right? The increase in your hourly pay. So to find out what your new pay would be, you'd have to say, okay, 14 plus 1.4, and that would be 15.4, or $15.40. That's one way to do it. Of course, the other quicker way, which I showed you in the last question, would be multiplying 14 by 1.1. And if you do that, you will immediately get your answer of $15.40. So feel free to use the second method here whenever you're doing one of these calculations. Now, if I had asked you, though, what is the dollar amount of the increase, then I would be looking for this $1.40 amount, and you'd have to tell me that. So pay close attention to what it is you're being asked in the particular question. In this case, we were asked what the new rate of pay was, so that's the total, right? That's how much you're getting paid per hour in the future. So again, pay very close attention to what you are being asked. Okay, another question here. A shirt is on sale for $14. The original price was $20. What is the percent discount? So this question looks a little bit different. We have a shirt that you're buying for $14. It used to be $20. And so we know the price has decreased, right? The price has been discounted. So maybe there's a sale or something like that going on at the store for a promotional reason. The question here, what is the percent discount? So it was 20, it's now 14. We know that by subtracting those two amounts that we're saving $6, right? 20 minus 14 is 6. The price of the shirt has dropped by $6. The question is, what is that as a percent, right? And you might be saying, well, wait, are we taking $6 as a percent of 14, or are we taking $6 as a percent of 20? The answer is $6 as a percent of 20, because 20 is the original value. So whenever we talk about a percent change, which we'll talk about in a minute, it's always out of the original amount. So $6 out of 20, right? Your portion over your base, right? That's going to equal your rate using that formula. So 6 divided by 20, that will be 30%. Or I should say, when you put this into your calculator, initially the answer you get will be 0.3, which we then know is 30%. We know that because if you move this decimal twice, the number becomes 30. So the answer to this, what is the percent discount, will be 30%. So there was a $20 shirt, there was a 30% off sale, now it's worth $14 and you save $6. That's the idea of what's going on here. So again, what we did was we divided the difference between those two by the original amount. So whenever we talk about percent change, you can always say that percent change, I'll call that PC, percent change, is equal to the new value of something minus the original value of something divided by the original value of something multiplied by 100. Multiplying by 100 because when you get that answer, you multiply by 100 to get the percent. Now, you might be saying, wait a minute, we didn't do new minus original in this question. We did original minus the new value. And that's just because the price decreased, right? If you follow this formula for this particular example, you would do 14 minus 20. You would get negative 6 divided by 20. Multiply by 100, eventually what you would get is negative 30%. The negative just indicates that the price decreased by 30%, right? So it doesn't really matter if you do new minus original or original minus new on the top of this equation. The only difference will be that your final answer is either positive or negative. But that positive or negative will just indicate if you've increased or decreased, right? So in the way I did this question initially, I did 20 minus 14. I didn't do new minus original. I did original minus the new price. And because of that, my answer was positive, even though the price decreased, right? There was a discount. So if you choose to ignore this order and just do the bigger number minus the smaller number, your final answer will always be positive, which is okay, but it will not give you that sign, positive or negative, which indicates whether or not the price has gone up or down. So it's kind of up to you. I would recommend using this equation, and then if you get a negative number, that just means that the value decreased, which is good information to have. Let's do another question where we use that same formula. So the question here is, enrollment in your college program is down from 200 students last year to 150 this year. What is the percent decrease? So they could have asked us just what is the percent change, and we would know that it decreased because it went from 200 to 150. But they told us it's a decrease. So in this case, I'll say my percent change or percent decrease, and you don't have to use PC here, you can use whatever variable you want, is equal to the original amount, which was, or sorry, the formula we're using is the new value minus the original amount divided by the original, right? So the new value is 150 minus the original, which is 200, divided by the original. The really important thing in this equation is that on the bottom, in your denominator, you're using the original value, right? Or the previous value, the original, the 200. 200 students enrolled last year, so that's our original. And then, of course, you multiply by 100 to turn it into a percent. If you do this, 150 minus 200, you get negative 50 in your numerator. When you divide that by 200 and multiply by 100, you're going to get negative 25. And this comes out as a percent because this 100 is 100%. So you can even include that little percent in your formula there. Negative 25%, that just means that we decreased by 25%. That negative indicates a decrease. That's all it means. So because this question said, what is the percent decrease? You could say that the percent decrease was 25%. You don't have to say the negative because you're saying the percent decrease is 25%. So you don't have to include the negative in your final answer. Just include the number portion of that and the percent. Okay, another question. A restaurant has 387 customers yesterday and 501 customers today. What is the percent increase? So again, they are telling us that it's an increase, but you can just treat this like the same question. Percent change is equal to, we'll say the new value is, we'll say the percent change is equal to the new value, which is 501, minus 387, because that's the original, divided by the original, which was 387. Again, I'm using 387 as the original because that was your value yesterday. That was your previous value that you had. And then we multiply by 100%. If you do this calculation, you will get 29.5%. I've rounded off my answer because there were actually many decimals, but that's okay. Just round off your answer. Typically on a test, I will specify how many decimal points I want you to round your answer to, but it's a little bit more than 29%. It's almost 30%. So it's an increase, right? We got a positive answer here. And that makes sense because we know the percent increased. We know that because we went from 387 to 501, the number went up. So we just figured out specifically what the percent increase was. Let's do another question. 30 dogs were adopted this month from the local shelter. This figure is down 40% from the previous month. How many dogs were adopted last month? So this question's a little bit different because we don't have the original and the new value. We're only given the new value, and we're being asked to find the original value. If you want, you can start with the same equation we've been using. You can say the percent change is equal to the new minus original divided by the original multiplied by 100%. And you can start plugging numbers in and try to solve for the original if you want to, right? So the percent change is 40% and it's down 40%, so we should actually plug in negative 40%. So negative 40% is equal to the new value is 30 minus the original. I'm just going to call the original x because that's what we're trying to find. And then we multiply by 100%. So at this point, you want to start solving for x. So I will get rid of this 100 first. I will divide both sides by 100%. If I divide this side by negative 100% and this side by, oh no, sorry, not negative, just 100%, divide this side by 100%. These 100% will cancel, and on the left, you'll be left with negative 0.4. Okay. Next step, I will multiply both sides by x. So negative 0.4x is equal to 30 minus x. This is just algebra, just isolating, same thing that we did in the last couple units. At this point, you can move this negative x to the other side, so it becomes positive x, and then minus 0.4x equals 30. I'll continue this work up here. I will combine these two things together. I have 1x minus 0.4x. That becomes 0.6x is equal to 30. And I will divide both sides by 0.6. So x is equal to 30 divided by 0.6. Right, I'm dividing both sides by 0.6 so that those cancel out. So x equals 30 divided by 0.6, and that leaves you with an answer of 50. So this means in the previous month, there were 50 dogs that were adopted from the shelter. So again, all I did was I started with my formula. I plugged in the percent change, which was negative 40%. I plugged in the new value. I changed the word original to x just so I had something a little bit easier to solve for instead of writing out the word original each time. And then I just isolated for x, and I got a value of 50. Now, that's one way you can do it. If you prefer, you could say something like this. You can say, okay, there's 30 dogs, and that 30 dogs, that number of dogs is down 40% from what it used to be. What this means is that 30 dogs represents 60% of the number of dogs that were adopted last month. So last month you had some number of dogs adopted. It decreased by 40% down to 30. That means that 30 is 60% of the original, because 60 and 40 together make 100, right? So because it decreased by 40%, what we have left over is 60%. So you could say 30 divided by 60%, and what this will tell you is how many dogs represent 1%, because I'm dividing 30 into 60 parts, right? If you do that, you get 0.5. 0.5, that many dogs, I know you can't have half a dog, but zero point 0.5 dogs would be equal to 1%. Well, I want to know what 100% was. I want to know what the original was. So multiply that by 100 and you get 50. So you don't have to use the original formula, the percent change formula, I should say, to always solve for x and figure out what the original was. Sometimes you can use some creative thinking like this to figure it out. And if you want to use a method like this, I am absolutely okay with that. I will give you the formulas that you need on the tests, but if you want to use a different method, something like this, and you figure it out, this is absolutely okay, whatever you're comfortable with. Now, there are some really good practice questions that I want you guys to look at just to get the hang of this. On page 134, that is unit 6.2, these are all about percents. So there will be questions where you have to change percents to decimals, and there are also questions where you're finding, what percent of this number is this number, or what is 10% of this number equal to. Basically questions that are similar to the questions we started with today. Then on page 142, this is unit 6.3, this is all about percent change. So questions that are very similar to the questions we looked at towards the second half of this lesson here. Take a look at those questions. I'm not assigning specific ones. They're all good. I would say go through and do one out of every so many. Just pick a couple questions just as extra practice, right? And do as many as it takes for you to get comfortable with this stuff. Those are all really good questions to look at. In the next video, we are going to take a look at some different terminologies that you need to be aware of, things that you'll have to know the definitions of in order to answer the questions, because a lot of the questions in this unit and on the upcoming test are going to be word problems. The math itself isn't too bad, but the struggle might come from turning those word problems into mathematical equations. So that's going to be what the next video focuses on.